Hello, this is Phil Thomas at New Era Systems. Today I'm looking at a VZU-6992. This is a 200 watt KU band amplifier, frequency range 13.75 to 14.5. This one has been sold. We're just running the final test before packing and shipping. It was tested a few months ago, but we always like to give a final test before they go out. Especially this one is going to Japan. If anything went wrong, to bring it back from Japan would be very costly and very irritating to the customer. It's been running for about 5 or 6 hours now. You can see the 1920 that's flashing on the front. So it's running about 19.5 watts roughly. To test it today, I'm using two other components. I'm using this frequency generator, currently set to 13.75, that's the bottom end of the frequency range, and it's running at 31.4 input, and that's giving about 20 watts roughly on the output side. I've got two ways of measuring the output on this amplifier. The most reliable way is using this Agilent power meter, and as you can see, the large figure is shown 43.67 dBm. The equivalent is 21.7 watts, and so you can see both on this power meter. Now, at the back of the amplifier, we need to look at something else. On the output flange, I've got a dummy load. That's this black radiator affair. That's absorbing all of the RF output. It would be a very bad thing just to have it spewing into the atmosphere. It could cause all kinds of damage to equipment in here, but also to me. Part coming out is the power head that's just connected to that HP unit that you saw a second ago. And if you want to think of this, it's a monitor port. And as I said earlier, there are two ways of checking the output. This is one. The other one is the display on the front of the CPI amplifier. This CPI amplifier has several different displays that are very useful. One of the things we need to know when we start getting up into the high output range, we need to know what the helix current is looking like. And we can find this simply by changing the display. The helix current at this 20 watts is very low. It's only 1.2 milliamps. That indicates a tube in very, very good condition. Now, as we get higher, if we start getting up into 6-7 milliamps, we know we've got potentially a problem with the tube. So what I am going to do, I'm going to run this up to, you see, I'm going to run it up to around 200 watts, and we're going to check on the helix current at that level. Now, I chose 200 watts because this has been tested before, and I know where the power range starts to drop off. And so instead of wasting a lot of time just inching it up a little bit at a time, I'm going to take it up fairly quickly. But don't forget, I've had this running all morning, so if there was any gas in the tube, then it's already been outgassed, because it's only a couple months ago that this thing was running anyway. So now let's go ahead, and I'm going to gradually increase. And the way I increase, I do it on the input side of the frequency generator. So you can see the helix current, and on the other display that you can't see, I'm going to gradually increase the power until I run it up to almost 200 watts. I'm up to 30 watts now, and I'm not seeing any change in the helix current. I'm up to 50 watts. Slight increase, that's to be expected. Now I'm up to 80 watts. Again, his helix current is changing, but quite acceptably. And now I'm up to 125 watts. And now I'm briefly going to take it up to 200 watts, because this is the theoretical maximum. I know this particular amplifier goes somewhat over, which again, that's not unusual in amplifiers. Sometimes they run less, sometimes they run higher. Okay, on my power meter, I'm showing 199 watts, and on the front display, we're showing 2.4 milliamps. Let's just see what this display thinks we've got, because they don't always agree with each other. Yeah, here, this amplifier thinks it's running at 176. The power meter thinks it's running at 199. Of the two, I would more likely trust the power meter than I would the front display. This has always been our experience in the past. But anyway, just to recap, We're running close to 200 watts, and on the helix current is now showing about 2.4 milliamps, which is exceptional. The next thing I'll do, I'm going to change the frequency up to 14.5. That's going to be the top end of the frequency range, and we'll see if it looks as good. But first I'm just going to decrease the power down to about 50 watts, and then I'll make the change to the frequency. Okay, there's 14.5 gigahertz, but I've also got to make a change on the power meter. There it is, 14.5 gigahertz. Now I'm going to look at the tab that I tested previously, and it looks as if we're going to run a little lower at 14.5, which again is quite normal. My previous test said it starts to get into saturation at about 178 watts. So I'm going to run the power up to about 170 watts, and once more check the helix current. Okay, we're looking at the helix current now, and on my power meter I'm watching the increase. The helix current shown there is at 51 watts. Okay, I'm gradually increasing it. I've gone up to 100 watts now. And helix 1.8, that's fine. Remember I said that it should be somewhere around 175, 78 before it gets into saturation. So I'm going to stop a little bit short of that. I'm looking at 161 watts now. 2.5, 2.4. Now I'm just going to take it up to 175. There it is. And at 175 we have 2.7 milliamp. Okay, there's confirmation of 175 watts. Well, that's it. This amplifier is in good condition. When I did my initial test, I was a lot more thorough. I took a lot longer to do it. But as it's been done once, I just wanted, this is just a verification process to make sure that nothing has gone bad in the couple of months it's been sitting on the shelf. Okay, I'm wrapping up now and taking it to pieces, and we're going to send it out for packing.